Miscellaneous question. Number 1. It is given that alpha equals to cos inverse of 8 over 17. Find without using the trigonometric functions on your calculator the exact value of 1 over sine alpha plus 1 over tangent alpha. So from here, we can say that cos alpha is equals to 8 over 17. So if we draw the right angle triangle, the trigonometric ratio of cos alpha is adjacent over hypotenuse. So this will be 8 and this will be 17. So that means the opposite side will be the Pythagoras. So this will be square root of 17 squared minus 8 squared equals to 15. So from here, 1 over sine alpha plus 1 over tangent alpha is equals to 1 over the sine alpha is opposite over a hypotenuse. So the opposite is 15 over hypotenuse is 17. So 15 over 17 plus tangent alpha is opposite over adjacent. So 15 over 8. So 1 over 15 over 8. So equals to 17 over 15 plus 8 over 15 equals to 25 over 15, or we can simplify it as 5 over 3. 1, 2 over 3. Yeah, it should be exact, so we can express in the fraction. Two, the acute angle x radians in such that tangent x equals to k, where k is a positive constant. Expressed in terms of k, the tangent pi minus x. So we know that x is acute, so it's in the first quadrant. So that means for tangent pi minus x, this will be in the second quadrant. We know that second quadrant, tangent is negative. So this is equals to negative tangent x. So this is equals to negative k. I tangent half pi minus x. So according to the diagram, I will draw the diagram. This is pi over 2. This is pi. So pi minus x is in the second quadrant. Half pi minus x, this will be in the first quadrant. And if you remember, if we use the value in the vertical axis, yeah, pi over 2 or 3 pi over 2, the function will change. So the tangent 1 over 2 pi minus x, this will be equals to cotangent x. So tangent change into cotangent, sine it change into cosine, and cos change into sine. So this is equals to cotangent x, and this is positive because in the first quadrant, tangent positive. So this is 1 over tangent x. So it's 1 over k. The third one, sine x. So to find the relationship between sine, cosine and tangent, we have to draw the right angle triangle. So this is x. We know that tangent x is equals to k over 1. So this is the opposite. This is the adjacent. So the opposite is k. The adjacent is 1. And the hypotenuse will be the Pythagoras. So k squared plus 1. So that means sine is opposite over hypotenuse. So it's k over root of k squared plus 1. Number 3. The diagram shows the graph of y equals to a sine bx plus c for 0 until 2 pi. Find the values of a, b, and c. So this is a sine function, yeah. A is the amplitude, b is the number of the periods, and c is the principal axis. If we see from the diagram, the principal axis will be 3. Yeah, because the 3 is the midpoint between the peak and the crest. So that means C, I can find C first. C equals to 3. A is the amplitude. So A is from 3 until 9. So A is 9 minus 3 equals to 6. So we check. So this will be 6 as well. 3 to minus 3 is also 6 here. So A is 6 and B. So we can see that the period from here to here, yeah, one wave is from 0 until pi. You see from the principal axis. This is the principal axis. So you can see that the period is pi. So that means the b is 2 pi divided by pi equals to 2. So the function is y equals to 6 sine 2x plus 3. I find the smallest value of x in the interval between 0 until 2 pi, for which y equals to 0. So y equals to 0, that means the x-intercept. So we can see from the graph, the first x-intercept is in here. Yeah, that is the first, the smallest value of the x-intercept. So we can find it using the equation y equals to sine 2x plus 3, and this is equals to 0. So 0 equals to 6 sine 2x plus 3. And then I can put it minus 3 equals to 6 sine 2x. So that means sine 2x equals to negative half. So sine negative half is in the third quadrant, yeah? Third quadrant and fourth quadrant. So that means the 2x is, find the sine inverse of this half. This is equals to pi over 6. So that means 2x will be equals to pi over 6. Sine negative quadrant 3, so the quadrant 3 is pi over 6 plus pi. This is angle in the quadrant 3. Plus k, times the period. The period of sine is 2 pi. So we have 2x equals to 7 over 6 pi plus k times 2 pi. So x is 7 over 12 pi plus k times pi. And we know that the smallest value after 0 is when k equals to 0. So x equals to 7 over 12 pi. If we check from the fourth quadrant will be 2x equals to 2 pi minus pi over 6. Yeah, from this value, yeah, 2 pi minus that value, plus k times 2 pi. So 2x will be equals to 11 over 6 pi plus k times 2 pi, and x equals to 11 over 12 pi plus k times pi. So if you use k equals to 0, you will have x equals to 11 over 12 pi, which is this one will be the second one. Since the question asks you to find the smallest value, so we only take this value. Number 4, write down the values of k for which the line y equals to k is a tangent to the curve y equals to 4 sine x plus pi over 4 plus 10. So in this case, if I draw, so this will be the principal axis. The principal axis will be 10, yeah, c equals to 10, and then a equals to 4, b equals to 1, because in front of 1 is 1x, in front of x is 1x, and we know that pi over 4 is the shifting, so this is the horizontal shift. Positive means it goes to the left. So for the original function, we will have sine start from 0, maximum at 90 degree or pi over 2, minimum 3 pi over 2. But now it shifts by pi over 4 to the left. So the 0 now will be at negative pi over 4 because it shifts to the left. So that means I can start the 0. Yeah, the 0 is from the principal axis from negative pi over 4. And then maximum at pi over 2, so it shifts to the left, maximum in pi over 2 minus pi over 4. So it's in the pi over 4. So maximum here. What is the maximum value? The amplitude is 4. So that means from 10, this is 10 plus 4. So this is 14. Yeah, the maximum will be 4 plus 10 equals to 14. And the minimum will be negative 4 plus 10 equals to 6. So the minimum will be 6. And then it's 0 again in pi. So shifted by pi over 4 to the left, it will become 3 over 4 pi. So it will be here in 3 over 4 pi. And then minimum at 3 over 2 pi. So we shift again to the left. So minus with pi over 4. So 3 over 2 pi minus pi over 4 is equals to 5 over 4 pi. So this will be 5 over 4 pi. So minimum here at 6 here. And then 0 again at 2 pi shifted by pi over 4 to the left. So this will be equals to 2 pi minus 1 over 4 is equals to 7 over 4 pi. So it will be like this. Yeah. Now, the tangent line y equals to k is a horizontal line, and it should be touch the curve only at one point. So that means it can be in here. Yeah, it touches the curve at one point. So this one is y equals to 14. And the other one can be in here at the minimum value. So tangent touch in one point. So the other values are 6. So the values of k, so k can be 14 or k can be 6. B. Show that 1 plus tangent over 1 minus cos theta plus 1 over minus tangent over 1 plus cos equals to 2, 1 plus sine over sine squared theta. So from the left-hand side, we will have 1 plus tangent theta over 1 minus cos theta plus 1 minus tangent theta over 1 minus cos plus cos theta. So I can make the denominator the same. So 1 minus cos theta, 1 plus cos theta, and this I have to multiply 1 plus tangent theta multiplied by 1 plus cos theta plus 1 minus tangent theta multiplied by 1 minus cos theta. And then I simplify the denominator. It's become a squared minus b squared. Yeah, a minus b and a plus b. So a squared minus b squared. So what squared minus b squared? Yeah, cos squared theta. So on the numerator, I will have 1 plus cos theta plus tangent theta plus tangent theta cos theta. And then plus 1 minus cos theta minus tangent theta plus tangent theta cos theta. So from here, I can cancel tangent and tangent, and then I can cancel cos and cos. So I have 2 plus 2 tangent theta cos theta over 1 minus cos squared theta. So from here, I can change tangent theta. So I factorize 2, 1 plus tangent I change into sine theta over cos theta over 1 minus cos squared theta is equals to sine squared theta. Use the identity, yeah? Sine squared theta plus cos squared theta equals to 1. So in here, I can cross the cos. So it's equals to 2, 1 plus sine theta over sine squared theta. And this is equals to the right-hand side. Hence, solve the equation 1 plus tangent equals to 3 for 0 under 360. So we can change this shape using this one. So 2, 1 plus sine theta over sine square theta equals to 3. And then do the cross multiply. So 2 plus 2 sine theta equals to 3 sine square theta. And then reduce it to the quadratic equation. Minus 2 sine theta minus 2 equals to 0. And then factorize. So 3 sine theta, this is sine theta. So to make it to 2, I have to, can we factorize this? Okay, I don't think so. We can factorize this. So that means we cannot factorize this. So we have to use the quadratic formula. So sine theta equals to, okay, minus b. B is negative 2, a is 3, and c is negative 2. So minus b, so it's 2 plus minus square root of b squared minus 4ac over 2a. So this is equals to 2 plus minus square root of 4 plus 24, 28 over 6. So that means I will have sine theta equals to 2 plus root of 28 over 6, or sine theta is 2 minus root of 28 over 6. So we try to find the values. 2 plus root of 28 divided by 6. So this is sine theta equals to 1.22, which is greater than 1. So this is not possible. And for this one, sine theta is equals to 2 minus root of 28 divided by 6. So this one is negative 0.549. So this is possible. So theta negative will be in the third quadrant and fourth quadrant for sine, yeah, sine negative. Okay, so I will move here. So the first one in the third quadrant, the theta will be sine inverse of 0.549. So I can find the sine inverse of this is 33.3. Yeah, if I am looking for sine inverse of 0.549 equals to 33.3. So on the third quadrant, that means 180 plus 33.3 plus period is 60. So equals to 213.3 plus k times 360. And since k equals to 0, the theta will be 213.3 without and not any period values, yeah, without any values. For the fourth quadrant, so the theta should be 360 minus this value, 33.3 plus k times 360, which is 326.7 plus k times 360. So when k equals to 0, theta will be 326.7. Okay. So we have two answers in this region. The function f is defined 0 until 810 by the function this. Write down the amplitude of f. So this is c equals to -2, a equals to 1, yeah, here 1, and b equals to 2/3. So the amplitude of f is 1. Find the period of f. So the period is cos is 2 pi or 360 divided by the b. So it's 2/3. So equals to 540. On the axis, sketch the graph of y equals to fx. So from here, we have the maximum of -2 plus 1. So this is -1. And the minimum of -2 minus 1. So -3. So it's only between -1 and -3. -1 and -3. So -1 and -3. And the principal axis will be here. So the period is 540. So it will become one wave for 540. And the normal cost will be start from the maximum again at 360, yeah. This one will be at 180, minimum in 180, maximum in 0 and 360. So it will be maximum at 0. So here. And because the period now is 540, so the next maximum will be within a period. So 540. And the minimum will be the midpoint. So 180 divided by the b. B is 2/3. So 540 divided by 2/3. So equals to 270. So this is the minimum. So for the first one, I can draw it like this. And that until 810, so the distance from head at the 10 to 540 is equals to 270. So that means from 810 minus 540 equals to 270. So it will be half of the width. So it will minimum here. So I can just continue this. 6. Show that the equation 3 tangent square minus 3 sine square minus 4 equals to 0 may be expressed in the form of cos to the power of 4, cos square, and a constant. So we have to change the tangent and sine into cos. So we have 3 tangent square x minus 3 sine square x minus 4 equals to 0. So 3 tangent is sine x over cos x square minus 3 sine square can be changed 1 minus cos square x minus 4 equals to 0. So from here, 3 sine square x over cos square x minus 3 plus 3 cos square x minus 4 equals to 0. And I have sine square again, so change again 1 minus cos square x over cos square x minus 3 minus 4, so minus 7 plus 3 cos square x equals to 0. So now I will have 3 minus 3 cos square x over cos square x plus 3 cos square x minus 7 equals to 0. Now, I can times everything by cos square x. So I have 3 minus 3 cos square x plus 3 cos 4x minus 7 cos square x equals to 0. So from here, I can rearrange. So 3 cos 4x minus 10 cos square x plus 3 equals to 0. So we have expressed in the form of cos 4, cos square, and a constant. Hence, solve the equation 3 tangent square x minus 3 sine square x minus 4 equals to 0. So the equation here, the same as this. So we can change this one into 3 cos 4x minus 10 cos square x plus 3 equals to 0. So we can have the quadratic equation here, and I can factorize. So this is 3 cos square x. This is cos square x. And then negative, so I put negative 3 here and negative 1 here to make negative 10. So that means I have cos square x equals to 1 over 3 or cos square x equals to 3. If we square root, so we will have cos x equals to 1 over 3, square root of 3, or cos x equals to negative 1 over 3 root 3. Don't forget, yeah, we have plus and minus. That's from the left side. From the right side, it will be cos x equals to root 3 or cos x equals to negative root 3. But both root 3 and negative root 3 are greater than 1 and smaller than negative 1. Since cos x only can be applied for negative 1 until 1, so we have to reject this answer. So the answer should be from the left side. Now we solve this. Cos x equals to 1 over 3 root 3. So that means the answer should be in the cos positive quadrant 1 and quadrant 4. But since we only need 0 until 180, so we're only looking for the quadrant 1. So that means x here is the cos inverse of 1 over 3 root 3. So this is cos inverse equals to 54.7 degree plus k times 360. And again, the k is 0, so f is 54.7 degree only, because if we put the period, it will exit the region. And from this one, cos negative in the second quadrant and third quadrant. But again, the answer should be in the first quadrant and second quadrant. So we take the second quadrant only. So that means x here will be the negative 1/3 is in the second quadrant, so it's 180 minus this value plus k times 360. So equals to 125.2 plus k times 360. So for k equals to 0, x equals to 125.2 degree. So we have two answers. 7. By first expanding, find the three solutions of the equations for 0 until pi. So we have cos theta plus sin theta squared equals to 1. So expanded into cos squared theta plus 2 cos theta sin theta plus sin squared theta equals to 1. So I can combine the cos squared theta and sin squared theta plus 2 cos theta sin theta equals to 1. Cos squared theta and sin squared theta is 1. Yeah, using the identity. Plus 2 cos theta sin theta equals to 1. So that means 2 cos theta sin theta will be equals to 0. So cos theta is equals to 0 or sin theta equals to 0. So we know that cos theta, the graph theta starts from 1, it 0 at 90 degree and 270 degree for cos, yeah. In radian, so this is pi over 2 and 3 pi over 2. So that means cos 0, the theta will be pi over 2 or 3 pi over 2. And then for sine, start from 0. So 0 at pi, 180, and 2 pi. So that means the theta sine equals to 0 will be 0, pi, and 2 pi. The range of the solution should be between 0 until pi. So that means we take pi over 2, we take 0, and we take pi. So there are three answers. So 0, pi over 2, and pi. And we have to reject this one because this is out of the range. Hence, verify that the only solution to the equation cos theta plus sin theta equals to 1 from 0 until pi are 0 and half pi. So verify means we can substitute the values to the equation. So for x equals to 0, we can have cos 0 plus sin 0 equals to 1. Cos 0 is 1 plus 0 equals to 1. So this is correct. When x equals to half pi, it is become cos half pi plus sin half pi equals to 1. So this is 0 plus 1. So equals to 1. So this is also correct. So x0 and x equals to half pi are the solution to the equation of this. B, prove the identity. Okay, so from left-hand side, I have to make the denominator the same. So this is cos theta plus sin theta times cos theta minus sin theta. And on the top numerator, I have to multiply. So sin theta multiplied by cos theta minus sin theta plus 1 minus cos theta multiplied by cos theta plus sin theta. So equals to, I expand sin theta cos theta minus sin square theta plus cos theta plus sin theta minus cos square theta minus cos theta sin theta over the denominator. It can be cos square theta minus sin square theta. So can we cancel something? We can cancel sin theta cos theta and cos theta sin theta. And we have cos theta plus sin theta minus sin square theta minus cos square theta over cos square theta minus sin square theta. We see that from here it should be only in sine. So I have to change cos square theta. So 1 minus sin square theta minus sin square theta. So I change this into this. And from the numerator, I can have negative, I put it in the bracket, sin square theta plus cos square theta. So this is 1 minus 2 sin square theta. And this become cos theta plus sin theta minus 1 over 1 minus 2 sin square theta. Yeah, don't forget the identity. So I can put it as 1. So this is equals to the right-hand side. C, using the result of A and B, solve the equation for 0 until 5. So the result of B is this. So we can replace the left part with cos theta plus sin theta minus 1 over 1 minus 2 sin square theta equals to 2 cos theta plus sin theta minus 1. So we have to simplify it first here. So I have cos theta plus sin theta. Okay, check the answer A2. A2 cos theta plus sin theta equals to 1. Has the solution 0 and 1 over 2 pi. So that means from here I can have, okay, just continue, negative 1 equals to 2 times cos theta plus sin theta minus 1 and then times 1 minus 2 sine square theta. And from here, so this is the same here. So I can combine this here. So that means 2 cos theta plus sine theta minus 1 times 1 minus 2 sine square theta minus, so I move to the right, cos theta plus sine theta minus 1 equals to 0. So in this case, I move this part to the right. Yeah, I combine it to become negative. Yeah, it becomes negative here. And then I can factorize this form. So cos theta plus sine theta minus 1. So I have 2, 1 minus 2 sine square theta minus 1. This is factorization here. So that means cos theta plus sine theta minus 1 times 2 minus 4 sine square theta minus 1 equals to 0. So from here, I can have cos theta plus sine theta equals to 1, or 1 minus 4 sine square theta equals to 0. Or I can have sine square theta equals to 1 over 4. For the left side, if we see from the answer in part II, cos theta plus sine theta equals to 1 from here has solution 0 and half pi. So that means in here, the solution of this will be theta equals to 0 or theta equals to half pi. And for the right side, I will have sine theta equals to 1 over 2 or sine theta equals to negative 1 over 2. Yeah, because the root of 1 over 4 is positive and negative 1 over 2. So from here, the theta will be, sine positive will be in the first quadrant and second quadrant. So the first quadrant of sine inverse half is pi over 6 times 2 pi, the period of the sine, but k is equals to 0, theta equals to pi over 6 only, because the answer should be in the region 0 until pi. Only quadrant 1 and quadrant 2. And for the second quadrant, the theta will be pi minus pi over 6 plus k times 2 pi, and this is equals to 5 over 6 pi plus k over 2 plus times 2 pi. And also for k equals to 0, theta will be equals to pi over 6 pi. That's it, without any addition from the periods. For the next one, sine negative half. The answer should be in the third quadrant and fourth quadrant. Since the answer should be only between 0 until pi, so we can ignore this. So the answers are 0, half pi, pi over 6, and 5 over 6 pi. So if we write in the order, so 0, and then pi over 6, and then half pi, and then 5 over 6 pi. So that's the answer. Number 8, a curve has equation of y equals to. State the greatest and least values of y. So we know that sine maximum 1 and minimum negative 1. So that means the greatest is 2 plus 3 equals to 5. The least is 2 minus 3 equals to negative 1. And then sketch, we know that the maximum will be 5. So the maximum will be 5, and the least will be negative 1. And from here, we can see that A is 3, so the amplitude is 3. B is half, so that means the period will be 2 pi over half equals to 4 pi. So since this is 0 until 4 pi, so it will be 1 period. So only one wave within this region. And then C equals to 2. So this is the principal axis. So we can draw the principal axis here. So this is 2. And the normal of sine is, it starts from the principal axis, maximum, minimum, and back to the principal axis. So it's maximum at 90, 0 at 180. In this case, we will use radian, pi over 2. This is pi. Minimum, 3 pi over 2. And then this is 2 pi. Maximum is 1. So the function 2 plus 3 sine half x, it can be started from 0 at the principal axis, so 0 degree, start at the principal axis, and then maximum 1 at 90 degree, pi over 2. Because the B here is half, so we have to divide by half. So 90 degree divided by half is 180. So it will be maximized at pi. So it equals to 5 at pi. And then at the principal axis at pi, so divided by half, it's become 2 pi. So principal axis at 2 pi. And then minimize at 3 over 2 pi. Divided by half, become 3 pi. So minimize at 3 pi. And then back to the principal axis at 2 pi divided by half. So 4 pi. So from here we can draw then like this, minimize, and then back to the normal, the principal axis. So this is the graph of 2 plus 3 sine half x. So from here we can see that the period of the graph is 4 pi. So equals of this, equals to our calculation. And the amplitude here is 3, because it started with 3. So that's the sketch of the curve. Next, C, state the number of solutions of the equation 2 plus 3 sine half x equals to 5 minus 2x. So on the left side is this function. So that means we have to find the intersection between the graph of sine and the line y equals to 5 minus 2x. The line 5 minus 2x has the gradient of -2 and y-intercept at 5. So if we draw the line 5 minus 2x, so it cut 5, and then the gradient is -2. So if the gradient -2, that means we have to find the x-intercept. So y equals to 5 minus 2x. So I can find the x-intercept, put y as 0, 5 minus 2x. So that means x will be equals to 5/2. So 5/2 is 2.5. We know that pi radian is equals to 3.14 radian. So that means 2.5 will be between 0 until pi. So it will be around, this is 3.14. So 2.5 will be around here. So we can draw a straight line passing through 5 and the x-axis here at 2.5. So from the graph, we can see that there is only one intersection point between the sine curve and the line. So the number of solutions of the equation is equals to 1. Only one solution. So this is the last question in this worksheet. Thank you for watching and enjoy the learning process. Bye.